In this video, we're going to look at impulse, where I, impulse, is equal to the mass times v minus the mass times u. And this is a vector quantity measured in Newton seconds, and we use the letter I. But let's build up to where this formula comes from. So we know from our mechanics formulas with our force and acceleration formula that the resolved force is equal to mass times acceleration. We also know that velocity is equal to initial velocity plus the acceleration times time. So if we take v is equal to u plus at, we can say that v minus u divided by t is equal to my acceleration. And if we sub this into my force and acceleration equation, we get F is equal to m times v minus u over t. And multiplying by t, the resolved forces over time, or these changing forces over time, which is going to be change in momentum. Jot that down as well. Change momentum, which is what impulse is. We're going to get m times v minus u, or mv minus mu. Now these are scalar quantities or vectors. We use I, they're measured in Newton seconds and so on. So this is the impulse formula you can see from above. So this is impulse. The changing forces over time is the change in momentum, and that's what impulse is. So let's have a look at a question. Or before we do, just you can be asked to state some of Newton's laws. So law 2, the rate of change of momentum is proportional to the applied force and is along the line of action of the applied force. We also have the principle of conservation of momentum. In the absence of an external force in a certain direction, the momentum of a system in that direction remains a constant. So this golf ball question, its mass 0.1. It's hit from rest, so we have this initial velocity is equal to 0, and immediately after impact it moves horizontally, which they are going to do in these questions. We're just looking at in the I direction at 60 meters per second, so the velocity then is 60. I find the impulse imparted. So writing our formula down for impulse, mv minus mu. So the impulse imparted on this golf ball of mass 0.1 is 0.1 by 60 minus 0.1 by 0, which is just 60 divided by 10, which is 6. And we write I Newton seconds. Now I'm going to do this one just incorrectly at the beginning, just to show you the mistake not to make, which I think if you make the mistake at the beginning you won't make it again. So tennis ball, m is equal to 0.05, and it moves horizontally at 8, so u is equal to 8, then it's hit, and v is equal to 18. So your instinct might be to write down your formula first always, mv minus mu, and just sub in 0.05 times 18 minus 0.05 times 8, which would be 0.9 minus 0.4, which would be 0.5. But look what's happening here. If the tennis ball is going horizontally in this direction, this is in the positive I direction, and then if it's hit back in the same direction, it goes in a negative I direction. So we have to be aware of this when we're doing these questions. So we'll take the tennis ball going in this direction first. So before, this is before it's hit back, it's traveling at 8, which we saw down below, is equal to 0.4. So that's what's happening before. Afterwards, the mass stays the same and it's traveling at 18, which is equal to 0.9, but it's in a negative I direction. So if we look at our formula for impulse, the change in momentum, well, it's now going at minus 0.9. We take away what it was going at, which is 0.4, and we get minus 1.3 I Newton seconds. Now, if you have the tennis ball going in the opposite direction first, it will just end up as 1.3 Newton seconds, and it will be along the line of the stroke. So these questions are fairly straightforward to start. We'll look at a bullet going through a piece of block in the next video, and we'll go on to some of the trickier types of questions.